ends up being 1 equals 1/2 raised to the n. What is n?
What is the concentration?
No, what is n? Mathematically. What's the value of n? N has a value. How do you get something equal 1 when you raise it to what power?
0.
0. So n is 0. See that? N is 0. All right. N is 0 there. Now, I'm going to do 3 divided by 1. Okay. These cancel. What is this? 4. This is 4. Right? A's cancel. Now, since this is the same as this, it's 1. We don't have to worry about it no more. So this ends up being 4 equals 2m. 4 equals 2m. What is m? 2. 2. So we know m is 2, n is 0. Okay? I'll give you a few of these to do. You'll get good at it. And plus, you're going to have to know this. I mean, this is part of your lab, too. And I've taught 1046 lab, and a lot of times students have trouble actually doing these calculations. All right, so now we can write the rate law. This is the rate law. If b is raised to the 0 power, it's going to be 1, so we can get rid of it. Anything times 1 is its value, right? So the rate law is the rate equals some rate constant, a raised to the 2nd power. That's the rate law. You see that? Now, there could be a, b, and c, right? And what you do is you eliminate one, right? You isolate 2 of them the same, and you focus on the 3rd one. But we're just going to worry about 2 of them, because 3 of them take a long time. That's how we got to the rate law. Now, to determine the rate constant, right, pick any one of them. Any one of them. So, if I'm picking the gray one, which is 1, I'd write the rate there, and I'd put in the concentration, square it, and that would give me the rate constant. Okay. You see how I got this number from here? This is the concentration of A squared. Ends up being 4.0 times 10 to the negative 3rd, 1 over molarity times second. That's the unit. Why? Because you have molarity times seconds on top, molarity squared on the bottom. Did you see how I got that? Yes? No? Maybe? All right. It doesn't matter which one. If the experiment went right, it doesn't matter which one I pick. They're all going to give me the same answer. Because they were all done at the same temperature and there's all the same reaction. But I'll put them in. I'll put them in. Okay. Do the yellow one now. Same answer. And I'll do the green one. Okay. So now I know K. Right? Now I know K. So, if I know K, at any concentration of A, I can give you the rate. concentration of K, of A, I can give you the rate. See? Alright. Fun. Alright. So A is 0.05 and B is 0.1, which doesn't matter what B is, because it's not part. It's not part of the rate law. I just plug in the number, and it gives me 1.0 times 10 to the negative 5 molarity over seconds. Be careful of the units. The overall rate law, the overall rate order, overall rate order is 2. M and N, the exponents added. 2 plus 0 is 0. So we answered the 4 questions there, right? All right. Let's go over it again. This was done in an experiment. Someone went into the lab, they did 3 experiments. Okay? They put A and B together, and then they had some marker that said the reaction went this far. A change in color, spectrometry, it could be anything, okay? But it says the reaction went this far, okay? And so they took the 3 experiments, right? Experiment 1 is the same concentration. Experiment 2, you doubled B. Experiment 3, you doubled A. Everybody see what they did there? And then the rate is something that they plot. Okay? The rate is something that they plot. Okay? Molarity, change in molarity over change in time. Okay? Now, the question is, using these data, the first thing is you're going to determine the rate law for the reaction, right? That you're going to need M and N. That you're going to need M and N. The rate constant, once you get M and N, you can write out the rate law and then plug in one set of data. That will give you the rate constant. The third thing, right? When the reactants are at a certain concentration, what is the rate? And you can determine that because you know the rate constant and you know the concentrations. And the last thing, the overall reaction, right, is this M and N or all the exponents added together. Those are the 4 questions. Any questions on that? Good. And then I do this beautiful PowerPoint, or I color for you. So what I'm going to do is take the experiment 1 divided by experiment 2. This is the rate law. The rate equals K, A times the power of M, B concentration times the power of N. That's 1. Divide by 2. Mathematically, you can do that. It's okay. Now, one of them is going to cancel out. The one that didn't change concentration will cancel out, and you'll be focused on the other one, which is B. When you solve for B, 1 equals 1/2. This is 1/2 right here, and right, and if it's the same power, you can divide. Okay. And so you know anything raised to the 0 power is 1. This must be 0. Do the same thing here. This ends up being 4. This ends canceling out. This ends up being 1/2 raised to the M power. 2. This ends up being 2 raised to 2 over 1 raised power, you get m and n. That's your first n and m. That's how you get, that's your first step. Now, you got a question?
Yeah. So, in order to find n and n, how do you know which m's cancel out and which n's cancel out in each of these?
Well, these cancel out because it's the same value. They don't
Okay,
really
gotcha.
cancel out as one.
Yeah, for sure. Okay, never mind. Okay.
It's one.
Yeah, I'm not supposed to.
Okay. Why do what?
Why did we choose rate one?
I could have not done that, right? I could have done, let's say, what could I have done? 2.
Yeah, we could have it.
1, 1. Well, you got to keep one the same, so they cancel out. So I could have done what? 1 and 3. Yeah, because 1 is 1, and then B is doubled, and then 3, A is doubled, 3. So you have to do it this way. There's no other way to do it. Because you're